Okay, section 3.2 A is on perfect squares and square roots. So first thing we're going to do is talk a little bit about perfect square numbers. And when we're finding the square roots of perfect square numbers, sometimes it helps to think of the perfect square number as the area of a square, and the side length then would be what we would have as our square root of that number. So for example, if you had an area of 16, a square of area 16, then because the side length would have to be 4 times 4 to give you 16, then the square root of 16 would be 4. So when we're doing, first we're going to just familiarize ourselves with the first 15 perfect square numbers. So if the number is 1, then the perfect square would be 1 times 1, or 1. 2, then 2 times 2 would be the perfect square, or 4. 3 would be 3 times 3, or 9. 4 would be 4 times 4, or 16. 5 would be 5 times 5, 25. 6 would be 6 times 6, or 36. 7 times 7 is 49. 8 times 8 is 64. 9 times 9, 81. 10 times 10 is 100. 11 times 11 is 121. 12 times 12 is 144. 13 times 13 is 169. 14 times 14 is 196. And 15 times 15 is 225. So those are the first 15 perfect square numbers. Okay, so you should familiarize yourself with these first 15 perfect square numbers, because it will help in this chapter and in chapter 4 as well, which we're only going to do sections 3.1, as I said, and 3.2, and then go on to chapter 4 before we come back to finish chapter 3. All right, so the first thing talks about some of the strategies in figuring out the square root of a number. Now, of course, you can always use a calculator, but without the aid of a calculator, this is a process that you can follow to help you determine if a number is a perfect square, or if it has a square root. That's a nice whole number. So the first thing you do is use prime factorization, this method here. So you would break down the 900 into factors and then continue to break them down into factors, to prime factors. So 9 would be 3 times 3, 100 would be 10 times 10, and then that would give you 3, 2 times 5, 2 times 5. So your prime factors for 900 would be 3 times 3 times 2 times 5 times 2 times 5. So this method of determining if it is a perfect square number, you basically group it up into two groups. So the factors of that, if you can break up the prime factors into two even groups. So we've got, for example, we've got 2 3s here. So one of those 3s can go here and the other one can go there. We've got 2 2s, so one of them can go here and the other one would go on the other side. And we've got 2 5s, so that one would go here and the other one will go there. So that gives us 3 times 2 is 6 times 5 is 30 times 30. So because 900 is 30 times 30, then 900 is a perfect square, and the square root of 900 is 30. So if we use that method again without using our calculators and try to show that 324 is a perfect square, we would have 324, 4 goes into that 81 times, and then 4 is 2 times 2, and 81 is 9 times 9. Now, you can actually go down one step further to 9 is 3 times 3, but I can see there that I'm going to have two perfect groups right now. So if you know that, you can go ahead and start breaking them up into two even groups, but sometimes you might not see till the very last step. So I'll just go down to the last step if you did have to break it down. So 9 would be 3 times 3, and then another 9 would be 3 times 3. So then if we split that up into two groups, we know that there's a 2 can go here and a 2 can go here. And we know there's 2 3s can go here, and 2 3s that can go on the other side. So therefore, our factors of 324 can be written as 6 times 3 is 18, 18. So therefore, 624. 324 square root is equal to 18. So we do the same thing here. Start breaking it down, 1296, and that would be 3 goes into that, 3 goes into that, 4, 3, 2, and that's a prime factor, so then we can break that down into, 3 goes into that again, 3, some of those digits is 9, which means 3 goes into it, so 3 goes into 4 once, with 1 left over goes into 13 4 times, with 1 left over, and goes into 12 4 times. So then that would be 3, 3, this is 12 times 12, 3, 3, 12 is 4 times 3, 4 times 3. And again, if you can see that there are pairs of numbers, you can stop your prime factorization and start separating them into equal groups. But if not, just keep going until you get to the prime factors, and then you should be able to tell for sure if there are equal groups. So in this case here, we have our 2 equal groups, so we separate them. We have 4 3s, so 2 of them can go on this side, and 2 of them can go on this side. So the 3s are taken care of, and then we have 4 2s, so that means 2 of them can go on this side, and 2 of them can go on this side. So that would mean we'd have 36 and 36. So therefore, the square root of 1296 would have to be 36, because 1296 is equal to 36 times 36. And if we do the next one, 1764, again 3 can go into that, so 3 goes into 17. 5 times with 2 left over, goes into 26 8 times with 2 left over, and goes into 24 8 times. 3, 588 would be, again, divisible by 3. 3 goes into 5 once, with 2 left over, goes into 28 9 times, with 1 left over, goes into 18 6 times. And then we break it down again. And 196 is divisible by 2. 2 goes into that 9 times, with 1 left over, 98. So then we have 3, 3, 2, and that's going to be 2 times 49, which I'm just going to add one more step. 3, 3, 2, 2, and 7 times 7. So there's our prime factorization of 1764. So if we break it up into equal groups, and just kind of squeeze it in over here, we have 2 3s, so 1 would go here, 1 would go here. We have 2 2s, so 1 would go here, 1 would go here. And we have 2 7s, 1 would go here, 1 would go here. So that would give us 42 times 42 gives you 1764. So therefore, 1764 is 42, because this here is 42 times 42, which implies that square root of 1764 is 42. So next we have a couple of problems. And the first one talks about Eric's rectangular shed having dimensions of 12 by 6. (12 meters by 6 meters) and has a square mat that covers half the area of the floor. So what is the side length of the square rug? So the first thing we'd need to know is what the area of the floor is. It's a length times width, which would be 12 times 6, or 72 meters squared. So therefore, half of 72 would be the area of the square mat. (36 meters squared), so therefore the side length, if we talk about the square mat, the side lengths would be the same, so it would be x and x, so therefore x squared would equal 36, and x should be the square root of 36, which you should know is 6, and it would be meters. Number 4, what's the side length, or what's the length of the side of a square farm which contains 1,764 yards squared of land? So if it's a square farm, then the two side lengths would have to be the same, and the area would be 1,764 meters squared, so therefore x squared equals 1,764. So x would be the square root of 1,764, which we just did a few minutes ago, or you can use your calculator and just put in the square root of 1,764, and you should get 42. We did that above in question number 2b as well, if you wanted to use prime factorization. And it would be yards, because we're talking about a one dimension. Now question 5 has a star next to it, which means that it's kind of a little bit more than what you need to know for the course, but if you're planning on going on to advanced math, or not, well, 2200, 3200, or doing the IB program, you should try these questions. So this one here basically is using the idea, just extending it to using variables. So if you are, and we will actually be doing these later on, and you will have to know them, but right now they're kind of considered optional questions. But if you think about it, they're not too hard, because this here, the square root of this basically, if you look at 9, 9 is 3 times 3. And x squared is x times x. And y squared is y times y. So in terms of if something is a perfect square, then it has a nice square root. So the square root of 9 would be 3. The square root of x squared would be just the x. And the square root of y squared would just be the y. If you look at the next one, you've got 36. So 36 a squared b to the 4. And again, you can break it down. 36 is a perfect square, 6 times 6. A squared is a perfect square, a times a. And b to the 4 is a perfect square, because b squared times b squared would give you b to the power of 4. So if we take the square root of 36 out, we get 6. If we take the square root of a squared, we get a. If we take the square root of the b to the 4, we get b squared. And if we multiply this expression, 6ab squared times 6ab squared, we will get back 36a squared b to the 4. So that is the square root. And this one here, 25p to the 10 w squared and t to the 6. So by now, I'm not going to write, this one's going to take too long to separate in all its parts, but if we just look at it, we know that the square root of 25 is 5. The square root of p to the 10 would simply be p to the 5. It's because if you look at what we did before, a squared was a, b to the 4 was half that, or b squared. So p to the 5 times p to the 5. If you think about that, that's p times p times p times p 5 times p times p times p 5 times again. So it would add up to be p to the 10. So that should be the square root of p to the 10. And w times w gives you w squared, so the square root of w squared would be w. And the last one, you would need t to the 3. Generally speaking, whenever you have an exponent, variable to an exponent, when you're looking for the square root, it would be like basically taking half of that exponent. So 5p to the 5w, t cubed would be your answer. All right, the next section in section 3.2, section 3.2b is on radical notation. And radical notation talks about the different parts of a radical. So if you have the symbol, the radical symbol, it's this kind of a, what you're familiar with calling a square root sign, but it can be a cube root or even a higher root. But the index is this little number that's in the corner, and that tells you, for example, if there's nothing there, it's understood to be a 2, and that means you're looking for the number which when multiplied by itself gives you the number under the root sign. If it's a 3, that means you're looking for the number which when multiplied by itself 3 times gives you the value under the root sign. If it was a 4, you'd be looking for the number which when multiplied by itself 4 times gives you the value under the root sign. So this index kind of indicates what how many times the answer should be multiplied by itself to get that value under the root sign. The number under the root sign is called the radicand, and this symbol right here, this part here, is actually called the radical symbol, nothing fancy, and the whole thing is called a radical. Okay, so if you don't see a number in the index, it's understood to be a 2, you have to remember that. All right, so the square root of 25 is 5, since 5 times 5 is 25, or 5 squared is 25. Cube root of 8 is 2, because 2 times 2 times 2, 3 times, gives you 8, or 2 cubed is 8. And 4th root of 81 is 3, because 3 times 3 times 3 times 3, 4 times, the same number as the index, right? Gives you 81, or 3 to the 4 is 81. And the 5th root of 32 similarly is 2, because 5 times 5 times 5 times 5, or 2 multiplied by itself 5 times, gives you 32. 2 to the 5, that's, and it matches up with your index, is 32. So the index of the radical is basically the same as this exponent right here. When the number that you're raising to that exponent should be the same exponent as what's in your index in order for it to be the proper answer. So first one here, we're going to identify different parts of radicals. So the first one is cube root of 5, so the index would be 3, and the radicand would be 5. Second one, the index would be 7, and the radicand would be 72. The next one, index would be 2, and the radicand would be 28. And the last one, the index would be a 6, and the radicand would be 4 cubed, or 64 if you want to write that. All right, so the next part of section 3.2 is on perfect cubes and cube roots. So similarly, when we did the square roots, we thought about the number that we're trying to find the square root of as the area of a figure, and then the side length would be the square root. So when we get into cube roots, we're basically talking about things that are multiplied by themselves 3 times. So we can kind of relate that to volume of a cube. And the volume would be the number that we're trying to find the cube root of, and the side length of the cube would be the cube root of that number. So for example, cube root of 64 would be 4, because 4 times 4 times 4 gives you 64. So 64 would be seen as the volume of the cube, and 4 would be the side length of the cube. So we're going to just familiarize ourselves with the first 10 perfect cubes. So again, 1 times 1 times 1 is 1. 2 times 2 times 2 is 8. 3 times 3 times 3 is 27. 4 times 4 times 4 is 64. 5 times 5 times 5 is 125. 6 times 6 times 6 is 216, I think. Yes. And 7 times itself 3 times is 343. 8 times itself 3 times is 512. I don't know the perfect cubes off the top of my head as well as the squares. 729 is 9 times 9 times 9. And most of you will know 10 cubed is 1,000. All right, so as with perfect squares, prime factorization can be used to figure out the cube root of a number if you don't have a calculator or have access to a calculator. But it helps to do this exercise anyway, just to help you understand how the calculator is getting the answer and what a perfect cube is. So it says use prime factorization to show that 1,000 is a perfect cube. So if we take 1,000 and break it down into 10 times 100, and then 10 is 2 times 5, and 100 is 10 times 10, and that would be 2 times 5, and 10 would be 2 times 5, and 10 would be 2 times 5. So if we split it up this time into 3 groups, because it's a perfect cube, we would have, there are 3 2's, so 2 here, 2 here, 2 here, and then we have 3 5's, so 5, 5, and 5. So basically that gives you 10 times 10 times 10 is 1,000. So therefore the cube root of 1,000 would be 10. So if we take that process now and basically just use prime factors to help us find that the cube root of 216. We can start off with 216 is 3 goes into that. 3 goes into 21 7 times and 6 2 times. And then we've got 3, and 72 is 9 times 8. And I'm going to move that up here, not a whole lot of room here. So this would be 3, would carry down, and then 9 is 3 times 3. And then 8 would be 4 times 2, or 2 times 2 times 2. Rather than do 2 separate lines, of break it down that way. So we have, again, you can see they're worked out real nice there, that the 2 groups, or 3 groups, if we split them up into 3 groups, we've got a 3 that goes in each group, and a 2 that goes in each group, because there are 3 2's and there are 3 3's. So that would give you 6 times 6 times 6 is 216. Write that down backwards, 216. So therefore the cube root of 216 is 6. Okay, so we do the same thing again using the cube root of 1728. So to find the cube root of 1728, use prime factorization. So if we look at factors of 1728, I know 2 goes into it, so 2 goes into 17. That would be 8 times, with 1 left over goes into 12 6 times, and goes into 8 4 times. And then the 2 can come down, and then 864 would be divisible by 2 or 3, because 14, 8, 6, and 4 would be 18, so let's go with 3. 3 goes into 864, 3 goes into 8 twice, with 2 left over, so it goes into 26 8 times with 2 left over, and goes into 24 8 times. So then that gives you 2, 3, and this is 2 times 144, which is going to be 2 times the 3, bring that down, and then the 2, and then 144 is 12 times 12, so then that would come down to 2, 3, 2, and 12 would be 4 times 3, which again would be 2, 3, 2, 2 times 2, times your 3, times 2 times 2, times your 3. So therefore, if we split it up into 3 groups, we've got 1, 2, 3 2s. So 1, 2 can go here, 1, 2 can go here, 1, 2 can go here. And then do we have another 3 2s? We do. 1, 2, 3. So we got another 2 can go in here, here, and here. And then we've got 1, 2, 3 3s left. So then it'd be 3, 3, 3. So that would give us 2 times 2 is 4 times 3 is 12 times 12 times 12. So therefore 17 square, the cube root, sorry, of 1728 should equal 12. Cube has volume of 4,913 cubic inches. What's the surface area of the cube? So that would mean that if the volume would have to be the side length cubed, or x would be the side length. So that means that we know that the volume is 4,913, and that should equal x cubed. So therefore x should be the cube root of that. So we can use our calculator for that. Doesn't say we have to do that by prime factorization. So you should have a cube root button on your calculator. And if you don't have a cube root button, or sometimes it's written above another button, like you might have to use a second function to get it, or you might have a button which looks like this with an x in the corner as the index, or something that looks like this. You may have to use that. Now, depending on which way your calculator works, some calculators you have to put the index 3 in first, then hit the second function of whatever key has this written above it. Then you have to put in the 4,913. Some calculators you have to put in the 4,913 first, then you would have to hit the second function of the key that has this written above it, and then you would have to put in the index last of 3. So in any case, you can check your calculator to see how it works. If you need help, come see me. And if you did the cube root, it should be 17. So that's the side length of the cube. So the surface area of a cube is 6 times the side length squared. So then all we would have to do is put the 17 in for x, square it, and then multiply it by 6, because you have to follow order of operations. So 17 squared times 6 would be 1,734 inches squared. And the next example is, I'll just move that up there. The next example is a rectangular prism which has dimensions 2 feet by 4 feet by 8 feet. What's the edge length of a cube with the same volume? So first thing we'd want to do is find the volume of the rectangular prism. Oops. And that would equal length times width times height, which is 2 by 4. I was going to write F. Erase that. 4 by 8, which would be 64 feet cubed. And it says what's the edge length of a cube with the same volume. So if it's a cube, the length and the width and the height would be the same. So we would need x cubed would be the volume, length times width times height would be x cubed, equals 64. So that would mean that x would be the cube root of 64, which would give you 4. And the last example there, basically you just have to work out, and these are square roots and cube roots that you should know. The square root of 121, you should know, is 11. The cube root of 216 we just did that a little while ago, was 6. So therefore, 11 take away 6 would be 5. And if you don't know those, you can stick them in your calculator and work them out individually and then subtract them after. Yeah, so 11 take away 6 is 5. And B would be cube root of 64 is 4, plus the cube root of 1,000 is 10, divided by the square root of 25 is 5. So following order of operations, you would have to do the 10 divided by 5 first, which is going to give you 2, and that's going to give you 6. So you got to follow order of operations. Put a little note there to remind you. Can't really read what that says. Okay. All right, so there's some questions on pages 146 to 147 of your text that you can try to practice this.